So my name is Joseph Gallegos. I'm with a company called GREYWATER, and we're going to talk about gray water and also a path to a net zero water building. The whole concept of gray water is just reusing water. And why do we do it? Basically, there's a number of reasons, anywhere from the city's EBW, which requires a reduction of water, LEED, Title 24. Title 24, especially in Los Angeles, requires all new buildings to be gray water ready. So people are thinking of why they should do save water, but it's just the right thing to do. And what's bringing that to attention is Greta. I mean, have you ever seen some of her videos and stuff? She's really showing us the power of what the young generation is thinking about the future of the environment. And so it's as a social and environmental ROI. So my job today is really to bring the two together, the policy-wise and also the environmental, and show how it can be a good thing to do as far as conserving water and moving forward. So, drinkable landscape. So typically on a landscape today, we're using about 46 gallons per square foot of landscape, and that's Los Angeles. That's a typical green lawn that you see in LA, where you see the water running off, or it's just really, really green. If it's managed, it's about 31 gallons. Drought tolerant is still 14, but it's 14,000 gallons for 1,000 square feet. That's the average size of a swimming pool, is about 14,000 to 18,000. So that's how much water is being used on even just a drought tolerant landscape, the desert looking. And with gray water, we're reusing water, so we're not putting any drinkable water on it. Now, what does that equate? What does that look like? Based on average, to survive with water, we need 2 quarts of water a day. So that turf somebody can survive with that same amount of water 92 days. But the takeaway is that for 1,000 square feet, you can actually have 77 people live off of that same amount of water for the full year. So it's quite a bit of water that we're actually just drinkable water that's being processed, being transported from Northern California, and just thrown on the landscape. So gray water gives a whole nother concept of being able to utilize water and use it efficiently instead of bringing that perfectly good water down. So what's 1,000 square feet? 1,000 square feet is equal to about 10 parking spots. So I'm just trying to give you a visual that when you go back to your car today and you count 10 parking spaces, that's 1,000 square feet. That's how much water that we just showed those numbers, how much is taken up for that area right there. So, and even a drought tolerant landscape in today's environment where we're pulling out lawns and putting in drought tolerant, it's still using quite a bit of water. Ideal places to really think about gray water is fast food locations. There's a lot of condensation up above. There's also the bathroom sinks that are being used constantly. So there's a lot of gray water in a lot of our buildings today that we really should think about. So 100% gray water location is a 0% drinkable water landscape. And that also cuts energy consumption. I don't know if people realize that 20% of all the energy that we use in California is to transport water from either the Colorado River or from the Delta down into the LA area or down into our metropolitan areas. And then once we clean it and then process it and throw it out in the ocean. So it's a big energy consumption as well to transport that water. Every gallon of water is about 10 pounds. So just think about that 10 pounds of weight being carried that full distance and being pumped out through those systems. So, but water is an enabler, and that's really the key here, is that water itself, if you start to really think about taking water and reusing it and giving it a second life, it allows you to do some really creative things with buildings. And not only just replace the water that's on the current landscape, but also having additional water to create these lush buildings that are sequestering carbon, cleaning the air, pollutants. So it takes a whole different layer than just conservation. And that's really a nice thing to think that when you're doing for your buildings out there. And what would you do with additional water? Would you try to create something like that, or create the trees? In the past, I gotta take this down. So in the past, we went to desertscapes, and in the process, you don't see many trees being planted. And today, if you start to think about reusing water, you can start planting these large trees that are going to shade the buildings. And especially when we start to have these extreme heat days of anywhere from 110 to 115 degrees. And what's interesting about that is that when they give you the temperature that's going to be 115 degrees today, that's the ambient air temperature in the shade. That's not the actual temperature out in the sun or on the blacktop. So it increases another 10 degrees to 15 degrees. So when you start to think about when you start having additional water, don't think of just not only replacing the landscape, but also what you can plant in addition to help fight urban heat islands or the whole aspect of carbon in the air. Policies I think are positive. I know sometimes we think, well, how can we get around the policy or how can we skirt it? They're actually thinking about that we're running out of water. And they say that the drought is over, but it's a surface drought. They're not talking about the groundwater drought. The groundwater drought is that our aquifers have gone down, our water's being depleted, so we have to really start thinking about it as individuals. What can we do to save water or to conserve water, to use it more wisely? Policies are only going to take us so far. Now, the idea is that a lot of times we're going to have excess water. So if you start to think about a tall apartment complex next to a freeway or a hotel or even a building complex, it's going to generate more water, more gray water than it could use in the landscapes. And the idea is to use it along freeways or in parks. It becomes an economic advantage. And that's kind of really where I see the market going to with gray water. I know right now we're only thinking about reusing it on the landscape, but it actually becomes a revenue source. So this is a typical apartment complex of 300 units. It's going to generate excess amount of water that is going to be a revenue source of $35,000. That's the equivalent of that 1 mile of freeway. Just driving down the 1 mile of freeway and knowing that all sides of it is being irrigated by that hotel or by the apartment complex or even by the commercial building. It starts to change the whole dynamics of your ROI too with gray water or reused water. Okay, so the days that need to be unlocked. First is the yuck factor. Everybody's thinking, oh wow, you're going to use somebody's old shower water in the parks, or you're going to reuse. But the easy one is the condensation, right? If you have a commercial building and you're pulling water from the condensation of the air conditioning units, that doesn't have as big of a yuck factor. As far as the local district transfers, San Francisco, and I've talked to the city of Los Angeles, they both allow for the transfer of water between one parcel to the other parcel. That allows for that economic model to start to work. The legal liability, that's still a concern that most people have about when we start to talk to them about the transfer of water between one building to the next building. And to mitigate that, possibly a middleman in the middle, being able to accept that water, make sure it's treated to a certain point before it's transferred over, or it's being transferred properly, subsurfacely. That's the real key in that area. Gray water sources. So a typical bathroom sink in a commercial building is going to generate the 1.5 gallons per employee. It's not much. And the showers and the laundry take in play when you have a apartment complex. So they can generate quite a bit of water in that oil. The real value is right here in the air conditioning condensation. Those units generate tons of water. As you can see, a 100-ton unit is going to generate 300 gallons a day. That's equivalent of irrigating 4,800 square feet of space. And that's quite a bit of landscape. Most of the buildings that I see around the general area, that's going to be able to meet those needs. I know of a building in Santa Monica that's generating 5,000 gallons of condensation a day during the springtime. It's just there's a lot of atmospheric vapor around our particular area. And it's going to increase. As the ocean temperatures increase, so does the vapor in the area where the condensation is coming from. And condensation is really just a matter of naturally distilled water. It's the water that's being evaporated from either the plants or from the ocean, and it's all around us. So it generates tons of water in the general area. Oh, I think I skipped the slide. So the path. What we see as a path is 3 stages. Stage 1, using the condensation for landscapes, grow trees, lush landscape. The trees help sequester the carbon, but also shade the building, cut your energy consumption. Next year, we're coming out with a product that's for toilet flushing, or other companies are also doing the same thing, taking that water and using it for toilet flushing and urinal flushing. Then in 5 years, we actually see that same condensation being cleaned to the point that it becomes drinking water, and that's big. And why that's big is because then buildings become basically water islands. So think about that. That's a net zero water building. It's self-sustainable. It's resilient within the urban environment. It becomes a source of supply in case of a natural disaster or man-made disaster. If we have a disaster, think about that you're able to go to the local, like Costco or Lowe's or Target, and knowing that those types of buildings are generating enough water to supply a certain population within that general area. Consistently, as long as it has power, okay? And that's the key is, if they have solar panels and they're net zero energy, but they also have the AC units and they have been converted to generate drinkable water, now those become little islands, independent water banks that we can pull water from. It also becomes a revenue source. So it's going to be a type of water that's naturally distilled, has low chemicals, has low impurities, and it could actually be bottled and sold in that aspect. So that's definitely the path that we see the whole industry going into. The economics. A typical 5-story building, this is basically how much it generates with the condensation. And that's the value, $38,000. We also show the estimated needs and the excess. So the excess is nice because now they're generating so much water that they're able to sell that to a local school or a local park. And we see it every day. We see these tall, large buildings, and they're next to a freeway, or they're next to a park, or they're next to some type of area. And the really nice thing about this is that it starts to create a economic model that you can easily justify to management or to the investors or to the readers. Anybody you have to answer, we want to do this conversion, and this is why we should do the conversion, and this is why it's going to pay off in the short run. So the future is definitely now. We're starting to plan for today, and basically going from a building design that is nice, you know, it's sexy, it looks cool, it's very clean lines, to what we really need in our urban environments are those green towers, those green forests, being able to capture the pollutants that are flying around, the small particulate matters, the car exhaust, and all that aspect. I'd really like to see type of buildings like that driving down the freeway and seeing that whole greenery up and down. So, as far as the tools So if you go to our website, we make it simple. You look under commercial and you look under facilities expo, you'll find the slide deck, but you'll also find a water worksheet. So you're able to do your calculations based off of, one of the things that's not on there will give you a air conditioning condensation worksheet too. So you take that and you're able to figure out how much condensation is going to be generated from your units. And then a tree carbon. I mention this because I'm a true believer in trees. That trees are a real big solution for a lot of our problems in our urban environments, and not the desert landscapes. It's really sequestering or taking the additional water and being able to grow those green landscapes to help fight a lot of stuff that we're having here. Feel free to take pictures. It's going to stay up, and my presentations are always fast. So this is about it, and now I'm going to answer some questions, and we'll go from there.
I'm just curious, is there like a city or anywhere, maybe another country that has a lot of this going on already, the buildings with the different outside?
Yeah, so Singapore is definitely one that's starting to utilize exterior type gardens, and there's two of them that are really popular, and I'll post them up on the website, or you find them on our Instagram. But there's one that's a hotel, and they did a second skin of an aluminum second skin outside of the hotel, and it has vines growing up the hotel, and it's a really beautiful building. The second one that's really popular is two apartment complexes, and they're next to each other in Milan. And if you go to our booth, you'll see the photo of the apartment complexes, and it's terraced all the way up, and it changes colors with the season, and it has all these great trees and everything else. Yeah.
Currently in Southern California area, what kind of cleansing and filtration is required for gray water applications that are in use right now?
So the question is, what are the regulations for gray water cleaning? There's two mainly. It actually classifies gray water in two categories. Untreated, which as long as it's delivered subsurfacely, you don't have to treat it. There's no issue.
So like through a perforated drain line or something underground?
Yes, exactly. It's a perforated drain line or a drip line or a mulch basin. For a personal pitch, we manufacture a special pipe that manages that type of application, that sits a foot underneath the ground and creates a moisture plume, and the plants feed from the moisture plume, a virtual water table. The second is what's called NSF 350, and it's clean to a certain quality that you can utilize the gray water for toilet flush or for traditional sprinkler spraying. So it allows you to keep the current irrigation system in place, but then clean it so you can actually disperse the water in that aspect. Another question? Any other questions? So I'll answer some that usually come up. First is soaps, detergents, items like that, chemicals. So every gray water system by code has to have a three-way valve. So if there's any harsh chemicals, the valves turn so that that type of, let's say if it's a bleach or it's a comment or something like that, goes to the sewer system. But typically, traditional soaps, hand soaps, shampoos, detergents, 30 years ago, I would imagine that they were very harmful, but because the consumers have pushed for something that's nicer on our bodies and for our health, a lot of those things have been reformulated. So we haven't found any problems at all with gray water utilizing soaps, conditioners, detergents. As a matter of fact, it's not a pitch for Tide, because we don't work for Tide, but we find that Tide detergent is a very good detergent for any type of laundry applications because it has a lot of surfactants in it. The surfactants allow the water tension within the soil to break up, and so the water spreads evenly across the landscape. We expect the same thing is going to happen with the sinks within an apartment and within a commercial building. They have a lot of surfactants to break up any of the oils that are on our hands. So That's a typical question. How about oversizing or sizing? If you go to our website, we'll have a sizing, so you can kind of calculate how much water you're going to need for your landscape, and then how many units or what the diversion should be, so that way you can kind of try to size it properly. Every system should have what's called a supplement valve. A supplement valve is, for some reason, the building's vacant. Well, where's the water going to come from? It's not, the air conditioners aren't turned on or anything else. So it's basically a valve that allows water to flow into the gray water system from potable waters or drinkable water and still mimic the same gray water application. Now, rainwater and stormwater are still considered gray water applications. And new designs today, if you're doing a lead design, we find that there's typically 2 layers of irrigation. You have your rainwater irrigation that's being pumped up from the cistern into the landscape. And then they have a second irrigation that's your potable water. So you're actually incurring cost twice. We have a system that actually combines those two. It's a non-pressurized system, so it allows you to push the rainwater into our subsurface irrigation as well as the potable water or the gray water. So you can use all 3 types of water all in the same irrigation system. How is that different than current applications? Is that most applications today, when you look at your irrigation, it's a pressurized system. So you have little emitters that are pushing water out, how many gallons per minute, how many drips per minute. So with this system, it's a non-pressurized. So the county code or the county advisors like the system because it's non-pressure. There's no chance of it being cross-connected into the public system. And that's the main concern. There's always a health code issue that you're worried about cross-connecting into the public, the public water system and contaminating. So that's kind of what they're really concerned about. As long as it's non-pressurized, then you don't have that problem. Questions? Yeah? No? Okay, so I'll answer a no one then. I guess you get it. Permits. Permits, so a non-pressurized system typically runs $300. A pressurized system that you have potential cross-connect is $2,400. So it's a big difference in the permit price. As far as water volume, typically 250 gallons and below is called a simple system. 250 gallons and above is called a complex system. So you usually hit the higher permit pricing at the higher volumes as well. So, cities that we see the biggest adoption of the systems, Los Angeles, because of the new code that requires all new buildings to be gray water equipped. And we're seeing an uptick in Santa Monica since they are what's called a water neutral city. And a water neutral city basically states that if I have a parcel of land and currently it's using 1,000 gallons, and I decide to build a 5-unit complex on it, and it's going to use 5 times that, I have to find the other 4 times from someplace else. You have to pay for somebody else to retrofit their property so I can pick up that additional water. So they're basically trying to set the limit that as much water as that city uses, that's the baseline. They don't want to go over it. So, okay, I think that's about it. If there's no other questions. Okay, thank you.
Click on the description below to find out where to buy the products. We also have links to instructions to how to build a gray water system. Be sure to subscribe to our channel and like this video. We would also love to hear your questions and also share how you prevent climate change. Put those in the comment section as well.